This is problem number 1 from section 5.4. In this problem, they say change each equation to its equivalent logarithmic form. And they give you 3 exponentials. Now, I have written here how to write an exponential to a logarithm. But there is kind of a special way that I like to do this. It's kind of like a looping method is what it's called. So, what we're going to do is we're going to take x equals a to the k. And if we want to write our logarithm, we're going to start with the base. And we're going to say, okay, log base a. And we're going to loop around the x value. And it's got to equal the exponent because logarithms give you an answer that is the exponent. So this would be log base a, that's where we start, of x equals k, which is the exponent. And you'll see that that's the exact same thing that's written right there. But I think of it as like a loop. All right, I start with the base, I loop to what it equals, and then I come back and I'm pointed at the exponent because that's what a logarithm's got to equal, is the exponent. So let's look at this with like part A. We have 11 to the 5z equals 5. I'm going to write this as a logarithm, so I'm going to say log right away. Now I'm going to start with the base. So base 11, so log base 11 of 5 equals 5z. So log base 11 of 5, right, that's the second thing we hit, equals the exponent, which is 5z. Part B. Now this has an e in it, so when we do this, we're going to use natural log instead of log. So we have e to the z equals 2. Again, we're going to write this time the natural log, and we don't have to write the base for natural log because natural log's base is naturally e. That's why I call it natural log. So e, so log base e of 2 equals z. So log base e, so natural log of 2 is z. You could also just write that as log base e, and that would be just fine as well. And finally, part C. We have a to the z equals f. So we're going to start with log base a of f equals z. So log base a of f, and we always equal for a logarithm the exponent, which is z. So a is the base of the logarithm because that's the base of the exponent. F is going to be, or in this case, whatever this exponential equals is going to be inside the logarithm as an input. And then the logarithm always outputs the exponent. And that's how you write exponentials to logarithms.